Hello, this is Mrs. Taylor, and I'm going to show you how to divide when there are radicals involved. So we have 3 examples here from your study guide. And the thing you want to remember with dividing is you always want to simplify first. Because if you don't, you can get into some pretty hairy simplification stuff down the road. So make your life easier, simplify first. And the first thing we want to do is try to divide things out if we can. Remember that just like with adding and multiplying, we're only going to work with like items. So what I mean by that is the 20 and the 4 in this first problem are both outside of radicals, so I can work with them together. And then the square root of 50 and the square root of 2, those are like items because they're both radicals, so I work with those two together. I can't combine the 20 and the square root of 2 by division because the 20 doesn't have a radical on it. So just remember, you work with like items. So with the first example, the first thing we want to do is see if we can make this easier by dividing. And so 20 divided by 4 turns out to be a whole number. So I'm going to go ahead and write it as a whole number, not a fraction. 20 divided by 4 is 5. And then the square root of 50 over the square root of 2, well, they're both square roots. So that means that I can divide 50 by 2 and simplify that as well. And 50 is divisible by 2. It's 25. But remember, they're in square roots. That square root has to stay there until I do something about perfect root factors. Now, square root of 25 just so happens to be a whole number. It's 5. So I can go ahead and write it as 5. And then 5 times 5 is 25. So this problem actually works out to be a nice, neat number. And all I had to do was divide some numbers and then take the square root of perfect square. Just to show you how you can check your work, one thing you can do is put your original problem in the calculator and compare it to your final answer. And so to put 20 square root of 5 over 4 square root of 2 in your calculator, you need to remember that your calculator needs to know what's on top and bottom of the fraction. And the way we tell your calculator that is with parentheses. So if I was entering this in the calculator, I need to put the entire numerator and the entire denominator in parentheses. So when I do that, it would look like this. I'd have parentheses 20 square root of 50. And I'm using an older calculator, so I've got extra parentheses there because of that. And then divided, and now I have to have a second set of parentheses to tell the calculator all of this is on the bottom. So 4 square root of 2, and I got 25, which is good because that was the answer I got when I did it by hand. Now, not all of these will work out to be whole numbers, so if that's the case, you may have to put your final answer in the calculator as well. But in this case, it was just 25, so I can just compare it. Alright, so let's move on to the next example. Now this one's got a lot of variables going on. So what I want to do first is see if I can divide any of the numbers. And see how this 4 is on the outside. There's no number on the outside up here, so I can't do anything to simplify that by dividing. There's a square root of 3, a square root of 5, but again, I mean, they're in radicals together, but 3 divided by 5, it's not a whole number, so I can't do anything with that. I have x squared over x. They're both in radicals, so I can simplify that. And remember, when you're dividing, you subtract exponents. So this is x squared. It has an exponent of 2. There's no exponent with the x. We understand that to be 1. So 2 minus 1 is x. So I'm going to start writing some of this stuff out. So I had that 3 still there. And I had the 4 and the 5 still there. But now I have this, instead of x squared over x, I just simplified it to x. X to the positive 1. And since it's positive, it goes on the top. And then I have a y cubed over y cubed. Some of you may remember that if you have the same thing on top and bottom, and it's being multiplied, which it is, they cancel. Well, why do they cancel? The reason is if I do 3 minus 3, I get 0. And anything raised to 0 power is 1. And when you multiply anything by 1, you get the same thing. So it's kind of like they're canceling. So that's nice. I don't have to work the y's anymore. They just kind of go away. And so what I have here is the square root of 3x over 4 times the square root of 5. Now, when you are simplifying, you have to remember that in order for your answer to be simplified, you can't have any radicals on the bottom. And there is a process to get rid of those radicals called rationalizing the denominator. And so we learned how to do that in class. And I just want to refresh your memory now on how to do that. So I have no plus or minus signs in my denominator. So that means all I have to do to change this so that there's no radical on the bottom is multiply top and bottom of the fraction by that radical. So I'm going to rewrite it down here so I have more space to work with. And remember what I said, multiply top and bottom by the radical. I don't have to do anything with this 4. It's fine being down there. I don't have to change it at all. So all I have to do is multiply top and bottom by square root of 5, not 4 square root of 5. Now let's say you forgot that and you did multiply by 4 square root of 5. It's okay. You would have multiplied everything out and then just had more simplifying to do at the end. But you would have arrived at the same answer that I'm going to arrive at. So no stress there. If you forget that detail, just keep going. As long as your algebra's right, you'll get the right answer. Okay, so multiplying across the top, both of these are in radicals. So I can multiply what's inside the radical together. 3x times 5 is 15x. And then across the bottom, 4 doesn't have a radical, so it's just tagging along out front. And then square root of 5 times the square root of 5, well, that's square root of 25. Now I need to do some simplifying. Square root of 25 comes out to be a whole number. And then I need to consider this 15. 15, what are the factors of 15? 5 and 3. Neither of those are perfect squares. So the square root of 15 simplified. And again, this x, well, if I try to simplify that, I have a root of 2. The x has an exponent of 1. 2 won't go into 1 with a whole number result. So the top's already simplified. And then all I have to do is multiply the 4 times the 5. There's my final answer. I no longer have my radical on the bottom, so I'm simplified. Now, what happens when you're in a situation like this one, where you have square root of 3 plus 2, and if I multiply by the square root of 3 top and bottom, I'm not going to get rid of the radical because when I distribute it, I'll end up with 2 square root of 3. It'll be back in the same place I started. So what that means is that now to rationalize the denominator, I must use the conjugate, which is what we learned in class today. So the conjugate is basically the same expression, just the opposite sign. So this has a plus sign, so my conjugate would have a minus sign. And what we learned in class was that when you multiply this out, you have some things canceling, and you end up with 9 radicals in the denominator, which is the whole point. So, multiplying this out, and if you need to review multiplying this out, you need to go look at the multiplying video, because I have examples of both these types of multiplication scenarios. Alright, square root of 3 times square root of 3, that's square root of 9. And then square root of 3 times negative 2, pay attention to the signs. Those aren't like items, so I just write them side by side. And then down here, I have to distribute each term in the first set to each term in the second set. So square root of 3 times square root of 3 is square root of 9. Square root of 3 times negative 2, not like items, so I just write it out. 2 times the square root of 3. Again, same situation, just have to write it out. And then 2 times negative 2 is negative 4. Now I have some simplification that I have to work on. On top here, I have square root of 9, which works out to be a perfect square. It's 3. And then on the bottom, I have a negative 2 square root of 3. And a positive 2 square root of 3. So if I combine them, it will equal 0 because they're opposites. So they kind of just eliminate, which is good. That's what we want. And then square root of 9 is 3, and then you have the minus 4. 3 minus 4, I hope you all can do that. That's negative 1. Now, to be fully simplified, I need to do any kind of dividing out that I can. And because it's -1 on the bottom, it's really easy to divide out, because when I divide both terms by -1, it just changes the sign. So my final result will be -3 plus 2 square root of 3. And again, just so that you know how to go back and check your work, I want to show you how you can use your calculator again to make sure you did this correctly. So going back to my original problem, which was square root of 3 divided by square root of 3 plus 2. If I put that in my calculator, so square root of 3 divided by, and all this is in the denominator, so the way I tell my calculator that is that I put it all in parentheses. So square root of 3 and then plus 2. Okay, press enter, I get that number. So I need to make sure it's the same as the number that I have written down here at the bottom. So -3 plus 2 square root of 3. So -3 plus 2 square root of 3. Oh, came out to be the same number. So now I know I did it correctly, because my simplified answer is equivalent to my original problem. So that's how you divide with radicals.